Okay. So just a quick disclaimer. So today I have a like a hard stop at 9:15 or 9:20 because I have a medical appointment to get. So I'll be not be having taking more questions today. So I'll be covering the topic, and if we have any questions, most of the questions we'll take tomorrow because table, as I say, table has a lot of topic, and I hope you will have a questions, and I believe you do have questions. So those questions, most of them, will take tomorrow so that we have the concept clear for all of us. Okay, so let us start on this. Okay, so objective, yeah. So as I will discuss about the data types of the table, different elements in the table, uh, how we are using our different table properties to do the inheritance, key properties, and temporary tables and queries. So queries we will also cover today on a small part, like what do I mean by queries and how we can do it for our own purpose in our development point of view. Okay, so this will be the agenda for the day. Okay, scenario, as always. So we have tables to store our data, key information, and tables are nothing but our rows and columns. So columns are basically our fields, what we call. So against those fields we are storing our data into each of the rows. It's how we define and create a table in Excel, or how we are creating a data in Excel. So it's similarly, it is called a table in Dynamics 365, or any data structure, any database. If you go, it's called a table because this is the simplest form of the data that we can store. Yeah, so first is the tables. If, as we are explaining the different scenarios for table, right, yesterday, I give you some data and some fields that I need to have a database based on these fields. So now you have to create a table, and you have to identify the type of the each field, and then we have to create that table. So for this is our step. So first I create my tables, then I set my main properties of the table, which is if this is a permanent table, if this is a temporary table, what will be my indexes. All these are very important basic properties. I'll come to that, but just to let you know, these are the things that we set first. And then we start creating the fields, which is our base enum and also our extended data types, right? And after that we go and do the build, definitely, to reflect the changes and create queries and and add the data source. Yeah, then if we want, then we can create queries, or otherwise we cannot, also will not be able to. If you do not create queries also, that is also good, because it's not mandatory to every time go and we have to create a query. Queries are mostly used to join two or three different tables and bring a set of data into our system. So let's assume we have uh, our customer table, which you're seeing yesterday. Then we have our customer transaction table, and then we have our customer transactions which are already paid. Okay, so customers have already paid. So let's assume we have three different tables. So we have our customer master data, then we have our customer transaction, which contains all type of transaction, and then third we have a table where we only hold the transactions which for which customers have already paid us, right? So for that, if we want to fetch some information based on all of these three tables, all of these three database, then we need to use a query. So that query will join basically. So I hope you have heard the term join, but you haven't. I'll explain also today. So this is kind of a technical thing that we will be discussing today. So as I was saying, so if we join those table based on the properties or the relations of the table, then we can create a query, simple. So, and that query can be actually used to fetch some information which we actually need. But just to store the data on a basic data like customer transaction, customer table, all those things, we just need to create a table. For queries are mostly used just to join those table, bring those selected set of information to us, and use that, and we can use that as our data source also, right? Because what happens, we have maybe three different forms, or what we call as UI, where I can go and see my customer data, customer transaction data, and also customer transactions which are already paid. But there can be some UI where we need to only bring those information, where we only want to see the information from all these three tables based on some conditions, right? So for that, we need to create a query based on all those three tables, and that query can be used as a data source into our forms. So in our forms, not only tables but queries can also be used as a data source. So these are the two I'd say data structure which we use mostly on a day-to-day basis, which is our tables and queries. So as I explained, let me demonstrate. So we have our table, which is our simple data structure, and then we have our queries where we store data from different tables based on our defined conditions, right? So as an example, we have our customer master table, which can be joined to our customer transactions, and that in turn can be joined which for customer paid invoices. So these three can be our tables, paid invoices, and based on these three, we can create a query and we can go ahead, and that can be used as a data source. So this is the concept of table and query. I hope this is clear to us. What do I mean by table and what is a query? Right now, about tables. So yeah, this is just like a graphical interpretation. So yeah, so it is best storing our business transaction metadata, all these things. Also one more thing, so if we are doing any type of configuration also in the system, that also being stored in our tables only. So everything whatever you are seeing, uh, behind that there is a table defined, and those data are being stored into those tables. Okay, so these are made up of rows which I explained, and this is kind of a small example. So these are different tables for a contract. So let us assume we have this master table, which is the contact, where we have our IDs, user ID, organization, employee ID. This is very evident, right? In every company or in every college or wherever we are maintaining this information. So against that contact there must be some addresses also, right? So maybe we do not want to store all those information in one table, so that we can use the contact, or rather a different table which contains only my address information, and that will be relayed to my contact table through my contact ID. Correct. So these are the relations that we do. So we can think, okay, why do I need to create so many different tables into the system? Because if we have only one table, and it will have then thousands of different columns. So today, against contact, I'll store my addresses, contact groups, personal information, organization information, email, all those information into one table. So that table number of columns will be huge, and retrieving data from that table will be quite a complicated thing. Correct, because the database size for that table will be quite huge, and retrieving those data will be quite a challenge, because whenever we are writing any query to fetch our records from the database, it is searching in all the columns. If we are not writing the code in a very specified filtered manner, it will search all the columns, and based on that it will bring the records and bring all the column informations actually. So let us assume, so I want to bring my like my address, zip code of my user ID. So in one of the table, if I have only one table, it has maybe 30 different columns. I write a select statement so by select statement, I mean I write a simple query in our SQL database or in our X++ code to bring the zip code information for my user ID. So I write a query where I give a filter for my user ID and say that bring me the information for that contact. If we do not write the code precisely, then it will, in that select statement, when it runs and when it hits the SQL database, it brings all the column information in that SQL statement. Okay, so that actually when it gets performed, so it decreases or reduces the efficiency of the system. So that is the, so time takes more, it takes more time, and when you have huge complex line of code and you are running so many different processes, we are always going for optimized performance, or the performance where we it takes minimum time, so which is a basic part, right? So that is why the data structure is very important. And whenever someone is saying like I have created a database or I have created a relational database, so all the database what we are saying like SQL or any other like Java any database whatever you are using, those things are actually relational database. So it doesn't have, like, it has maybe 5 or 6 different tables and all of us can store all the information in one table. It will always be comprising of different small table where we can define the relations, and based on our relations we can bring and fetch records. Okay, so this is the idea of the data structure. It's a simple, very simplistic manner, so where we have one contact and all the other information is stored into different tables. Okay, so now if I show like how a table looks like, okay, I'll show it from the system just now, but these are the different elements of the table, and I'll show it now in the system. So this is a table, these are my fields. So fields, at least as of now we understand what is fields. So fields means my different columns, and where we can have our different fields, and based on the type of the field, it can be an enum, it can be an extended data type, and that extended data type can be of date, can be of date time, can be of string, can be of boolean, all these fields, right? So these we understand, these parts I'll explain once I show it from the system, but yeah, just understand these are the major components of a table. Okay, yeah, so about field groups, I will field groups, I'll show you what are the field groups. So field groups are nothing but so can I show it from now? Okay, I'll show it from the system only. Okay, so field groups are nothing but there is a concept of field groups in for tables. So field groups are nothing but is a type of field groups, so like commonly used fields which can be clubbed to create a field group. Let us take an example. In the customer data, if we see, let's take an example from here. So let us see from here. I go and open my, let's say, supplier record, okay, which is my all vendors. Okay, so let us assume I open this vendor account. Okay, so this is my supplier account, supplier master data, which I'm showing you, right? Master data. So if you see, it has so many different, yeah, see, it has so many different sections, correct? Addresses, contact, miscellaneous detail, vendor profile, demographic, invoice and delivery, purchase order default, payment, tax, retail, financial, all these are different components. So against this table, against this form, the main table is the vend table, which is our vendor master table, which is called vend table. So under that, and also this address, contact information, these are not exactly coming from vend table but coming from different related tables which are actually related to vend table based on some conditions, correct? So these are my like a structure of database where my base table is my vend table. Based on the vend table, I have my addresses, this address. If you go and check the table of the addresses, it will not be vend table, it will be a different table, it will be third party address table. if you similarly go to my contact information, again this information, phone, email ID, contact number, it will not be vendor master table but a different table which is actually related to my vendor table. But other than that, this general information, all this information, or if you go to this vendor profiling or purchasing demographics, all these things, let's say for invoice and delivery, we have this, all these informations, offset account, invoice account, all these things, these will be found in vend tables, right? So you can imagine, so only this section contains maybe 10-15 different fields, so each of the different section will have so many different fields. So if you go to the payment section, it will have so many, like method of payment, terms of payment, bank account, all those things we need to mention. So each section can contain 10-15 different fields. So right now I can see here at least like 150 200 different fields are there in the vent table. So if I ask you, and if I ask you to go and do any changes in the vent table and bring some information into this part, let's say I ask you, okay, under the payment, I need you to add one more field which will show me another information. Let's say assume, and this is a customized field. So if you go and create that field, if you add that field to a vendor table, and then you have to go to your form, find this design where this payment is, and then you have to attach that field to that form. So that's a very complex process, or not the best way to do it. So the best way to do is, under vent table, if you can group fields uh, based on some properties, like, these are my payment fields, and I will need to show them in a different section. So I will create a field group named payment. Under that field group, I will mention what are the fields which are needed. Okay. Similarly, if I need, similarly for invoice and delivery, I go here, I know what are my invoice fields needed related to my invoice. I go and club them in and create a field group, correct? And that field group, when I create or design this UI, or what we call as form, I go and use it in the field, into the form. So under the invoice and delivery, we do not go and create each field by one. So I am not going and adding, here I am selecting first, adding invoice account, then offset account, then number sequence, all these things I do not do. I simply go into the form design. Under this section, I marked the field group as invoice and delivery from the vent table. So once it is marked, automatically if you open the form, all these fields will come. Okay, so this is the idea behind the field group. So, and this is very useful actually, right? So as I was explaining, if I ask you go and create a new field from the payment section, you simply have to create that field in your vend master table and add that field to the payment field group. Once that is added, you build your solution and you will be able to see the changes into the payment section, because in the form section, this payment field group is being used into this section, and if you add one field into that field group, it will automatically reflect here into this payment section. Okay, so this is the idea of the field group, and this is very important for doing large scale customization or large scale form design. But sometimes what happens, if you are going and creating small customizations, or like creating a table and creating a small form, or where the data is very simple, or kind of a list structure, right? Then maybe you do not need to add a field group. But the best practice is always, remember, these are like Microsoft best practice, always whenever you are having creating a table, you understand and you know what my fields are, you have to create a field group, and in the form you can create the field group. So if you do not have a field group, but then also Microsoft suggests you go and create a default field group. And if you go and if you have a small form, like see, this is a very complex form. Let me show you something very small data structure, like Okay, see, again, this section is also critical, but okay, like forget about these sections. Let's say we have only one tab here, which is list, which only shows me the journals, invoice journals, open invoice journals, and you have a like a simply row and column structure. See, this is a very easy structure to understand, right? You have the number, name, description, posted on, all this information, correct? Modified by, right? These are very simply easy to understand. And assume that you do not have all these sections in the form, you do not have so many buttons, you simply have a new and delete button, save button, and you have a list of data, nothing else is there. So the structure of the form looks very similar to a table only, right? Because in table also we store the data accordingly, it only have rows and it only have columns. But then also Microsoft suggests you to create a default form group where it will show default, and you add all the fields which you want to see into the default field group. You keep on adding field group and it will appearing here. Okay, so this is the idea of the field groups. Okay, so yeah, again remember best practice checks for field groups, this is important. So whenever we are creating a field, so that is also very important to understand. Okay, so yeah, now fields and field groups will show from the system. What is my fields? Okay, so this is a small table we I can show you. Okay, so these are the main elements of a sales of a table. So as I was explaining, right? So this is a, like a master data. Uh, so this is I'll take the questions later today. So and if you have anything, so I believe if you have questions, so just let me know. I'll answer it to you, and or all of you have my email ID or phone number. Just drop me a text, okay? So yeah, so these are the number of fields. Okay, so as I was explaining, so if I ask you to go and select any field and try to do anything, so that will be very difficult for us to perform. So what we need to do, we need to define our field groups, and based on that we can go and work for. So this is the concept of the field group. So if you go to the field groups, you will see all these field groups are there, right? See, where we have defined different sections. So here we have all our different sections for a sales table, right? So let us show you the example of the main table only, that will be helpful, which we just discussed. So this is my main table, which I was which show you, right? Okay, so fields, as I was explaining, it will have different fields. Do not go into all the details because there are few fields which are country specific, few fields which are specific to different modules, like for tax or for our compliance related things. So it might be very confusing and intimidating, but it's not that critical, because on a regular basis maybe 50% of the fields we are using, but rather than that there will be so many fields which are actually being used for different country specific or different fiscal specific things or compliance related issues, right? So yeah, so let us go to the field groups and see. Here you will always definitely you will find a few of the field groups are default in all the tables. This summary, report, lookup, these are by default Microsoft creates. And then we have our all this invoice information, contact information, memo fields, payment, posting, purchase order defaults. All these field groups are actually we created. And then if you open that form, when I'll show you, you will see these field groups are mainly being used into the form. We guys do not go and add each and different fields, right? Okay, the next section for a table element is our indexes. So by indexes we mean how fast or we can retrieve the data. So whenever I am creating my indexes, so indexes are nothing but our retrieval of the data from the database. So if I have, so you will, if I go here and show you, you will have different indexes. So but mainly major index, this is a primary index. For any master data, we define our index based on some numbers, correct? You have maybe your account number, or maybe your party number or something like that, right? So those indexes are very important. And what are the type of indexes, I'll explain later, because we need some more understanding on indexes later, because that's a, like a critical thing to understand, and how we can create different indexes and how we can use that to our own benefit in the table properties. So that I will explain later tomorrow, because I've like designed a session for indexes and properties tomorrow. But yeah, just to let you know, indexes are uh, to expedite the process of fetching the record from the database. And if we define the index, it helps the database to retrieve the record fast and to maintain the database consistency. Okay, so that is a major part of the indexes. So again, we have defined different indexes because few of the fields, as I was saying, base maybe because for different countries or different demographics. See, for taxes, we have created few indexes. For Brazil, so for BR means Brazil. So for Brazil, we have created few indexes. So those things, few of the things, you might be confused or seeing so many things, but remember, this is a global application, and whenever I'm seeing something from the database or from the application window, it will contain every element for all the countries or for all the important. So we may not be considering all those things, but the things which we need to learn is the basic stuff, and that we are will be concentrating on. So next is our full text indexes. This is not used much. This is actually basically is nothing but like is whenever you are creating a quick search, right? So indexes, I meant if you are fetching the record something, but if you have some big string data which we call memo field, which contains maybe 1,000 characters or more than 1,000 characters. So if you want to fetch some record or do a quick search on that data, large volume of text data basically, so we need to define a full text index. So what do I mean by that? Let me give you an example. So if you open the same form, which is our all vendors, let me show you something for the memo field. Yeah, see this purpose text. See, this is this field. If you see the size of the field, right? This is kind of a big size, right? Why? So these are like maybe 15, 20 characters. Here you will have like very specific character, but this purpose is basically it contains a huge size, and this can contain maybe 1,000 characters or 2,000 characters based on the properties on the module set. Because these purposes and all these things we cannot write in maybe 5 or 10 text. We have to go and write some different elements, or maybe 200, 300 different characters. So that also is allowed in Microsoft Dynamics. It doesn't, like, we only can store few information. So now you can understand, right? We have few columns where we have data maybe for 5 characters, 10 characters, and right now we have a column where the column size is huge, where we are storing a data for 1,000, 2,000 characters. And now if I tell you that I want to fetch some record on the purpose text, so your normal indexes will not work. Okay? So what do I need? I need a full text index, and that is why it is being used. So if I want to have a large volume of text, which is kind of this example, and if you want to do a quick search on that, then only we want to use the full text indexes. Okay, so that is important for us to understand. So what is the full text? But again, this is not much used, I would say, because whenever we are storing the data, we generally don't go and do a like a full text index search. So that is not recommended also, and we do not use it much. Most of the important things are my indexes, right? Okay. Relations, we have like if you go and open, there'll be so many different relations you can see, and if you go and open, you can see the type of the relations, all these things. Mostly major things I will be discussing more tomorrow, but let me demonstrate what are the few of the relations type. And this is like a very, I'd say, very informative. If you know the concept, it will help you to understand the other part also. So we have indexes, or rather, sorry, relations. Relations simply mean if you are joining the tables based on how, what are the relations we have, right? So first is our normal relation in a table. I'll explain them, but just we just write the types. First, then is our field fixed. Third is what we have. Then we have our, what do you call, related field fixed. Related field fixed. And fourth is our foreign key. Foreign key relations. Okay. So these are the four type of relations what we have. So quickly, let me quickly explain. Normal relations are nothing but if we are going and adding a relation to to two tables based on some fields. So let us show you that. So if you go to relations, if you go to your currency, so maybe, and if you see, so our vendor table has a currency, and the currency table, which is a currency master table, will also have a currency code. So these two is a relation what we have maintained, correct? So a vend table currency is equal to our currency code, simple. So this is a normal relationship. So where we maintain a relationship which is based on my based on a simple field. So this is our normal relation. So if I expand that, so this is, I can see, and this is a normal field, correct? Okay. So if you open these relations, you can see this kind of information. I'll explain this more, but here we can see this all the properties of the relations, and what what exactly each properties are. I'll explain, but just to let you know what are the related table, all these things. We can cardinality. These are like more in-depth concepts. So it will take time, but we'll do that this tomorrow. But these are my first major type, which is my currency type. Okay. So now the second type, which is my based on field. Okay. Second is my field fixed relation. So field fixed is nothing but if we are defining relation between a parent table and a child table. So we know the parent child concept, right? So a master data table is always is like a parent table, and if we have some relation with some master small other tables which are my other like transaction table or something, so those are called child table. So if you see this example, if you remember this slide, yeah, so this I can tell as a master table. This is my contact information, okay, and all my addresses, emails, all these are kind of a child table because my contact information is actually related to my addresses. So this is my kind of a parent, and these are my child concept, correct? So now, if you see and if you open this, yeah, if you go and see the field fixed relation, so I define a relation based on a field where we can only restrict the data from the parent field. So it's basically restricting data from the parent based on a specific relation. So what do I mean by that? So if I am having a relation between my parent and child table, and I am using a field fixed relation, then whenever I am running a query based on that relation, it will only show us the data from the parent table, whichever is present in parent table, based on the field fixed, or the based on the field which we have defined the relation on. So previous example we have seen our when table and also our currency table have a relation based on the currency code, correct? Now if I have created that as a field fixed relation, so and then I go and write a query based on my index, which is based on my relation, which is a field fixed relation, it will only restrict the data from the parent table based on that condition. Okay. Similarly, the related field fix is the opposite one. We restrict the data from the related table, or which is our child table. So it's like a, if I just go and just copy paste the same thing, but it's the related table. So here similarly, if I have that parent and child, but I am using a relation based on the related field fix, so it will fetch only those records which are present in the child table, or what we call as a related table, based on that condition. Okay, so this is one more thing, and we have our foreign key relation, which is nothing but, so foreign key field. So let's say in our primary table or our parent table, we have a field which is our foreign key, or we call as EDT. Let's say we have a field called account number, and that account number is a primary key field into another child table. So it's basically maybe it is being complex, but I'll show it to you now. So it's like a foreign key field, foreign field in parent table to the primary key. So what do I mean by primary key? What do I mean by foreign key? This is nothing but, my primary key is nothing but the primary table field based on that which I am do my database retrieval. So which is actually the first thing whenever I am inputting my data, that field will be important, which is my primary key, and which is actually important to retrieve the data, to fast to expedite the process of retrieving the data. So the foreign key is basically let's assume in under the when table, what can it be an example? Maybe invoice account. So let's say I have under the Venn table as a field for account number, correct? So this is my field which is being used in here as a field, and this field actually is a primary key into another table, which is my invoice account here. So that means under Venn table, that account number field is a EDT, or is a field. That field is being used in a different table, or as a third party table, this one invoice account, with in that table that is a primary key. So this is how we define the foreign key relation. So in one master table we have our one of the field that being used as a primary key table in another table. So if you go and see what is the other table, it is my not this one, it is okay. Let's assume this one, payment term. So this payment term ID is a normal field in my vendor table, but in this table, payment term table, it will be the primary index. So that can be a defined as a uh, of foreign key field, right? So this is the idea behind the relation. Okay, so if I go and explain the other part, so we have our relation indexes. We understood the delete actions. I will explain. State machines. I can give you some idea, but you will not understand once you learn the workflow and mappings and events and method. Is will be learning when we have to know the code part or when we just do the coding part, which we do it on Friday. So yeah, delete action, another important thing. So what do I mean by delete action? So whenever we have related tables, so I am showing you so many different relations in the table, correct? So that means if I delete something in my major table or which is my parent table, I should also delete those records in my child table, which is a cascading action, correct? So this is my delete action, which is very obvious. My delete actions. So first is my cascade action, cascade delete, what they call. So it's nothing but I delete in my parent table based on the relationship what is mentioned. It will go and delete into the other table. Okay. Maybe if we have worked with some database or some Excel also, we know that if I delete some data in some column, it goes and deletes into the other sheet and goes and delete into the other Excel sheet, because we have defined some relation or we have defined some properties, or use some formulas or something like that, correct? Try to map that with the same concept. If we have under vendor master table, if we have in one set of data, we have defined and created a relation with my vendor transaction, then I go and create a vendor record for vendor one. Let's say vendor one, I delete that record in my vendor master table. If we use a cascade delete, system automatically goes and deletes all the record across the system where that vendor one record is present. Be it transaction, be it invoices, be it posted invoices, be it any other information related to vendor one, it will go and delete those information from all the tables. It actually helps us to saves our time, and also we do not need to worry that there will be junk information present in our system, because if we do not know how many tables is being used with that vendor table, and if you have not defined that relation, then what happens, maybe okay, I have 5 table in my mind, I can go and delete those record in my 5 tables, correct? But maybe someone else has also been using that information into other 3 4 different tables, so that you only delete the 5 tables, but there are some unwanted or junk data which are present in the other 3 tables. So once you do a database synchronization, full compilation, it will throw you errors that there are orphan records or junk data present into the system, and you will not be needing that thing, and we need to remove, like do not need to go in that route. So what do? We define our relations, correct? We define our normal, fill, fix, or all these relations, and then we go and create our delete actions, which is my first type is cascade delete. If I go and similarly, let's say if I see this payment term I showed you, right? Let's say I have this payment term table is my master table. Here is not, but let's assume this is my first parent table and this is my payment term ID. And we have in the vendor table, all the vendors have some payment term ID. Now in the payment term, if we go and delete one payment term, let's say that is payment terms is maybe 30 days. So I need to payment in 30 days. And if I go and delete that record of 30 days, it should go to my vendor master table and delete all the vendor record which has payment terms of 30 days, as simple as that. And also it should go to all our my customer data where the payment term is used, and all the date tables where this payment term id is being used. And how do we do that? We do that by defining our relation first, and then we use the cascade delete. Similarly, we have another delete type which is called our, I think it's called cascade restricted delete. It's called restricted delete. Okay. So what do I mean by restricted delete? Restricted delete is nothing but you have the relations, but you are only restricting that delete in for one table. So that similarly, that example which I am giving you for restricted delete, I only restricting my delete action into the one table. So that option is also there. Okay. So this is the delete actions which we have discussed. Okay. uh, the state machines is I briefly explain. So is actually when we have workflows, so it actually allows us to perform state transition in the workflow, because when we learn the workflow engine, we'll see that's a different engine actually built on top of Dynamics 365. And when we are going and trying to do some work in that workflow, it changes the state of the database. Okay, so with the state machine, we if we have allowed the state machine, it allows us to perform those state transition in the workflow. So just for now, just learn this is for the state machines. Okay. Methods and events are nothing but how we are writing the code. So in the methods is basically under the table, if we want to write out business logic, you will find so many different methods, which can be my insert method, which can be my delete method, which can be my on like init method, all these things, right? So if we go to and show my methods, so you will see a lot of different methods are there, correct? So once I, because these methods are written, and here we write our business logic also. There are 2-3 ways we can write. So in the table we can go and write it, and this will show us what are the things which we have written. So these are for my business logic. So these are my methods. And events are nothing but how we are actually writing the course. So if you see this event called on inserted, that means when I go and create an event on inserted, that means I write my business logic when the record is inserted into the table. Correct. So maybe some database manipulation, or some database few specific information you need to put when the records are inserted. How will you write the code? You will go and create an event on the on inserted method, and you will write if it is a pre-event or a post-event. If that is a post-event or pre-event, that we will explain when we do the coding, but this is for our events. Okay, these are mainly where we go and write our all our business logics. Okay. Okay, so if you are clear on this, then mappings are basically nothing but we have like we can wrap 2 or 3 labels. So it's an X++ element which can actually wrap. So it can kind of a if we have multiple tables, it can wrap those multiple table objects at runtime based on some conditions. So again, this is for our data retrieval and for our using. So we'll explain that later, but this is kind of a complex part, because maps are being used at a runtime mostly when you are running complex code or running complex objects. Okay, so we'll wrap up the session today now. If you have questions, do one thing, just write me an email, or if you have anything, just drop me on WhatsApp. Tomorrow we'll go and again discuss more on the tables. We'll see each of the properties, because under relation, if I show you, we have so many different properties also, right? We need to know all these properties. These are important, and we need to know the properties, what do I mean by each and every relations. And we also have properties for my parent table, because these properties are very important. What do I mean title field, what do I mean by see primary index, table group, all these things, these are also important. So these properties and relations, all these things we'll learn tomorrow. We'll have a session on this because these are very important to know, because like not for interviews also, but for building the data structure also, and to know these properties, how this behaves, that is very important for us to know. Okay, so we'll have the session on the properties and the relations indexes tomorrow on this one. Okay. Okay, so I'll conclude the session for today here, and we'll take the questions tomorrow, and we'll discuss more on the properties tomorrow. Thanks everyone.
Thank
Have
you,
a good day.
Maitreya.